now. So what was I going to say is that, okay, so this is what's going to happen. So we're going to do, so last week, right, not last, on Tuesday, we ended our final portion on SQL with the triggers. So we are now entering into a second part of the program, which is on database design, and that will entail a few things. So first thing today will be on modeling, and then subsequently we will look at how best to design databases. Probably by we will complete modeling everything by next week, and then we have the midterm. When the midterm, or rather when the term reopens again, we will look into the quite functional dependencies. Yeah, that is a really that's a big and not a big, but that's a portion, a good topic to go through, a big topic to go through. Then thereafter, we will switch gears. We look into how much time we have. We may go directly into MongoDB, or we may go into web API. So we will at that point of time, we will see at the time how much time we have, and what is the best way to proceed on. And the reason why we are doing this is that I think I want to make the course as relevant as possible. So instead of going a bit too theoretical, which is also good, but I think one thing that's also important is that for me personally, I think maybe I just want to make it a little bit more more practical. So which is why we are going a bit more into some of the more practical stuff. That's my alarm, and that's the first thing. And the second thing that I also want to let you know is that currently SQL databases only form one part of the tool. So next time when you go to work, SQL is like the basic form of databases that you need to know. Many new databases are coming up. So just the past week, I had two requests for me to look into graph databases or social network analysis. So I think, and when I look into the job requirements now again, I find that SQL is just one component. They usually now put SQL, MongoDB. These two are like the like you need to have, and then they sometimes put one more, which is a new 4J, which is graph databases. So I try to cover as much ground as possible. And after all, in this introduction to databases, NoSQL also forms part of what you need to know. Yeah. So that's a bit on my introduction. Okay, so if there are no further questions, the test quiz will start at 9. So we will give about 10 minutes break from 8:50 to 9 p.m. So I only have a few more minutes to go. Yeah, wait, one more thing. So our midterm is going to be the week after on Tuesday morning. So I think what I will do is next week, Thursday, there will not be a lecture. So it will be replaced by the midterm, which is the week after on Tuesday. So we will not eat up your time for that. So if that is fine, let me know. So next week, Thursday, there's going to be no lectures. I think we should be able to complete our material for the first half of the tutorial for the first half of the course right on time. Next week, Tuesday, we'll see how it goes. We may have so-called. I may give you a mock midterm as well for us to go through. Okay, let's go into the lesson properly. Thank you for your patience. Okay, so today we are going to go through a very important topic, which is called database modeling. So we've been talking a little bit on this, on the data model versus the conceptual model. So we've been talking a lot about the ER model, or rather the entity relational model. We've been looking at it all throughout the trimester, but we just didn't really give it a proper, so-called a proper term to that. So what we have, the tables that you have, right, they are basically called entities. So whatever table that you have, those are called entities. So entities. So let's say school and students. So you have the school student. So this is the entity. These are what they call entity, and this will be the relation. So this will define the relationship between two of the so-called two of the entities. not traditionally, that has been what we've been looking at for the entire trimester. So ER model will relate to the relational model. O model will be all the rest. For the time being, we'll only look into the ER model right now. So in terms of abstraction, what we have is that we may have the parts of how different data is being linked to one another. So for example, you may have look at these are the parts that are really linked to one another. Maybe let's go through this table first to make it a little bit more clear. So let's say you have entity A, and you also have entity A1, and you want to say that A is a parent of A1. So if we look at what we have learned all along, which is the entity relational model, we would model this as a relationship of a parent-child. Okay, so likewise for A and A2, if A2 is a child of A, this is also how we are able to model this relationship as. And so if this kind of relates to a tree-based logical model like this, where I have a parent and I have a child and I have another child here. So these links, this relationship are actually represented in this table over here. The quantity tree refers to this number 3 that we have over here, number 4, this number 4 over here. Likewise, A1 has also two children, which is A11 and A12, and that is how we represent these relationships. Okay. So typically, this has been what we've been doing so far, and what we've been trying to model. Whether in a way, the logical model of what we are doing is actually derived from this over here. This is an example. Of course, this is the relation, and these are the entities. So we have A, A1, A2, A11, A12, which are all the different so-called objects that you see over here. Okay. So yeah, so essentially we are designing a so-called a logical model using relational database. Yeah. So this has been what we've been going through. So this will describe the entity, the attribute, relationship, the key. So entity is, as what we said earlier, this is the entire let's say the student. We have SID, S name, everything. Attribute will be one single thing within the entity. Of course, we also naturally have the relationship, which is how are two entities being related by, and we have the key, which is how we use to uniquely identify a certain row within a table. Okay, so we are not good. This is just a lot of revision. So identity is a thing or object. So for example, in a class, it is a student. If you look at it from the O point of view, that is like an instance, which is like the student Amy. So if you look at the O point of view, it is like the instance Amy. Okay, so far. Okay. So attribute so-called labels used to describe the entity. So as I said earlier, so CID is attribute, C name is attribute. So let's look at this. So an entity will usually have multiple attributes. So for example, this is a student table, and they have attribute like ID, name, let's say age. So these are all attributes. So yeah, they have gender. So these are all attributes, and the instance of it can be like both the ID, the name, and the gender of it. Okay. I hope this is yeah, clear. So of course we have this is something that I didn't really cover a bit. a lot. This is where we have a composite attribute. So we said earlier, if I have an address and I put it together as one single attribute, let's say address, where I have the block postal together as one single attribute, this will be a composite attribute. So we mentioned that this is not really encouraged. This is not really encouraged. What will be a bit better is that we would split it into block, postal, yeah, and whatever lah. So this is this is sort of the encouraged form to do it at, and we have a unique we have a term to call this, which is called first normal form. Okay, so we will go through this later on. I think over this 1-2 weeks we'll go through this first normal form. We also have a derived entity. So for example, if let's say we have the birth date, we can well derive the age of a person. So these are the two other attributes that are there. Of course, we have the key, which is the attributes that are used to identify the object instead. So we have the candidate key and the primary key. Yeah, so candidate keys are whatever attributes that can be used to uniquely identify a certain row in your table, and primary key is the key that as a database administrator you decide to use that as the key to identify which row to uniquely identify your row. Okay. So now we have we come to how we draw the ER diagram. So a relationship captures how entities are related to one another. So relationship is, let's say I have, this is I think we all know this is a 2-degree relationship. So there's an arrow relationship, and it's 2-degree with two we have two arrows pointing in here. So every student and course will be in this way, SID, CID. So this 2-degree will then correspond to the two attributes over here. Similarly, if you have a relationship with 3, you may have SID, product ID, project ID. So in this relationship, it is of 3 degrees. So it will be not surprising that you will need 3 attributes in that table. So that's why we say that the degree of a relationship will infer the number of entities in that table. Okay, so this hope this is fine. And there's also a very unique instance called a row, which is a 1-degree relationship. And this one is like a parent and a child. So as what we said earlier just now, or rather the example that we showed earlier. So there's A1 and there's A11. So this is a parent and child relationship, and this is a 1-degree relationship. So let's say like that, right? Remember just now we had this example. So this is a 1-degree. So there's only at any point of time only one line is entering or leaving a particular part. So these are all 1-degree relationships. Okay. So we have n-degree relationships that we seen earlier. Then we can represent in a 2-entity table or 3-entity table depending on the degree. And we also have 1-degree relationship, which we can just represent as a single table, as what we have seen earlier. Okay. Okay. The next thing is the cardinality. Cardinality refers to mapping. So let's say if I have 2 entities, A and B, I want to map between do a mapping between these two. cardinality will then define how I can map these two. So for example, A and B, let's say this is 1:1. One instance of A can only be linked to one instance of B. So for example, a country can only have one capital. Yeah. So likewise, the capital can only have one country. Yeah. So it's a one-to-one relationship. Let's think of another one-to-one relationship. I'm trying to think of one. Can anybody here give me an example of another one-to-one relationship? Okay, maybe I can. Yeah, what is another one-to-one relationship? Okay, let's say a student and exam grade. No, this is not one-to-one also. Yeah, so let's. Okay, I can't think of one right now. So funny. Okay, so sorry, I can't think of one right now. Okay, student. Yeah, student. I see. Yeah, very good. So NRIC maybe to student ID. So one NRIC, yeah, 9 something something, can only be linked to one student ID, and one student ID can only be linked to one NRIC. Yeah, very good, very good. Yeah, thank you for helping me, Sean and Zixuan. Yeah, so that is a one-to-one relationship. 1 to M is that one instance of A may be linked to many instances of B, but a member of B is only linked to one instance of A. So for example, a child can only have one biological mother, but the biological mother can have many children. Yeah, so this is an example. Yeah, so like I can have many phones, but the phone's owner is only one person. Usually the case. So this is right. M to N is A may contain, so there are many instances between these two. So for example, author can have many books, and a book can also have many authors. Yeah, so a piece of a person can write many software, and the software can also be written by many people. So so if we want to map cardinality, this is somewhat of how we do it. So so if there is a, if let's say there's a 1 to M relationship between this and this. So one employee can only belong to one department. So that's department. But one department can have many employees. So that's why I have employee someone two and department 001. So 001 has many employees, but each employee can only belong to one single department. Okay. And how do we interpret this? The way to interpret this is that one employee can have many departments, and one department can also have many employees. So this is M to M or N to M. Yeah. So this is how we describe that. So for example, 72 has 2 departments, and 002 has several employees as well. Okay, I'm just doing a time check and realize that it's 8:50 already. Yeah, you all need so long for the test. I think I can go 5 more minutes. I think I can go 5 more minutes. Yeah. Let's do a bit more fast. Yeah. So minimum card. Let's say if I want to represent something like, okay, why are we studying this? Right? It's because later on we'll be looking at this whereby if let's say I have 2 entities and they have a relationship, what is the cardinality between these 2 entities? So that is why we are studying this, and we need to write it down in terms of the numbers and the ratio. And that's why we are doing this. This is what they call an entity relational diagram. And we typically use these entity relational diagrams to then create our tables. So that's why we are studying this. And let's say if there are two ways, or rather not two ways. Earlier we talked about these three mapping relationships between two entities. And following on, this is the next one, whereby if I were to define M to, or rather if I were to define something like this, I can well define that this is a 0 all the way to M, or 1 all the way to N, which means that one of these can be linked to, let's say this is a course and a student. So this means that one course can have 0 to M students, or if I have this, but if I write this, it means that one course can have 1 to N students. Yeah, so this is what this slide is trying to say. So this is the minimum, and this is the maximum. Okay, so when you have total participation, your minimum cut is equals to 1. It means that there must be somebody there. There must be somebody there. If partial participation means that maybe there's nobody there. So let's say if my one course, right, let's say my course is not offered this trimester. So the number of students taking is 0. So that is by default a partial participation. Courses are partial participation. Yeah. But usually colleges, right, usually is total participation. You cannot be you cannot be a school with no students. Then close down already. Yeah. So usually schools will be total participation. Okay. So yeah. So so not now actually implies that it is a total participation, because there must be something that is there. So partial participation is when it is now, or there's and when you put a now into, or rather when it's possible to put a now as one of the values in the attribute, then of course you can put it to be a partial participation. Yeah. Okay. So when do we do something like this? So for example, if you want to have a discount, so discount of all products, discount of products for all customers is 5% off. Then naturally you may want to do if let's say, right, if let's say you must have it for all customers, then there will be a total participation, and you may have something that looks slightly like this, where it is a total participation. So none of the attributes can be now. Okay. Okay. But if let's say there is a chance whereby, depending on the product or depending on the customer, you may want to offer or you may not want to offer him discount. So you will offer now, you are able to offer now values in my attributes. So for example, in this, what I'm trying to say is that for product 01, I'm only offering customer 01 a 70% discount. So for example, senior SVIP, only for product 1 is a 70% discount. And for customer 01, for all others, for example, it can be a 80% discount. Okay? Or for product number 1, I can for all my products in product number 1, I can have a 90% discount. And for all other products, not in these two, I can have a 90, or maybe sorry, I should say a 5% discount. Yeah. Okay, so this is something that, yeah. So remember, in I think the quizzes I did ask, or either the quiz or the mock quiz I asked about this discounting. whereby are we able to, how can we redesign the table to give a discount? This is actually a way that we can manage this situation. Okay, so I wanted to complete this at least so that at least all of us we go through this example lah. Okay, okay so far. Okay, so if all is fine, let's take maybe an 8 minutes break. We'll come back at 9:05 for quiz number 2. Thank you so much for your time, and I'll see you all in a while's time.